What we're going to do in this video is build on our knowledge of conditional statements by exploring three related forms: the converse, the inverse, and the contrapositive. We'll think about what it means for two statements to be logically equivalent and see how we can determine whether two compound propositions are equivalent. Now, I have a statement here on our screen. If Abby lives in Los Angeles, then she lives in California. Before we dive into the math, I encourage you to pause the video and identify the hypothesis and the conclusion of this sentence. All right, let's look at this together. Our hypothesis, P, is Abby lives in Los Angeles, and our conclusion, Q, is she lives in California. Once we identify the hypothesis and conclusion, we can create other forms of implication by swapping them and adding negation. These forms are called the converse, the inverse, and the contrapositive, which we will examine one by one. Before we proceed to each term, remember that this applies only to implications or conditional forms of logical propositions. In other words, there is no converse or inverse of a conjunction or disjunction. All right, the first one is the converse. The converse of an implication means we simply swap the hypothesis and the conclusion. So our statement becomes, if Abby lives in California, then she lives in Los Angeles. As you can see, the hypothesis of the original statement becomes the conclusion of its converse, and the conclusion of the original statement becomes the hypothesis of its converse. Therefore, in general, if our statement is P implies Q, then its converse will be Q implies P. The second one is the inverse. To find the inverse of an implication, we keep the original order but negate both parts. In the inverse, there is no need to swap the propositions. We keep the hypothesis and conclusion of the original statement as they are, but we add negation to both the hypothesis and the conclusion. Therefore, the inverse of the original statement will be, if Abby does not live in Los Angeles, then she does not live in California. As you can see, we kept the positions of the propositions the same, but both now contain negation. However, when we evaluate the statement, just because Abby does not live in Los Angeles, that does not imply that she lives outside California, because she could live in San Francisco or another city in California, right? In this way, you can evaluate the meaning of these forms. In general, we can say that if our statement is P implies Q, then its inverse will be not P implies not Q. The final one is the contrapositive. When we deal with the contrapositive, it is like a combination of the converse and the inverse. We do both. We swap the positions and negate them. It looks like this. If Abby does not live in California, then she does not live in Los Angeles. Here, we swap the hypothesis and conclusion of the original statement, and we add negation to both of them. Therefore, if the statement is P implies Q, then the contrapositive is not Q implies not P. The statement we found suggests that if Abby is not in California, then she is definitely not in Los Angeles. Since Los Angeles is in California, one cannot be outside California and still be in Los Angeles. Therefore, the statement we found has a meaning that aligns with the original statement. This is called logical equivalence, which we will see using a truth table. Now that we're familiar with the three forms, let's see them in a truth table. Let's say the original statement is P implies Q, so our converse, inverse, and contrapositive are shown here as follows. Since we have two propositions, we'll have four possible truth value combinations. Therefore, we have P, Q, negation of P, negation of Q, P implies Q, then the converse of P implies Q, which is Q implies P, then the inverse, which is negation of P implies negation of Q, then finally the contrapositive, which is negation of Q implies negation of P. Then the truth value will be as shown on the screen. As we can see from the truth table, the original statement and its contrapositive have the same truth values for every possible combination. When two compound propositions have identical truth values in all possible cases, they are said to be logically equivalent, which is expressed using the symbol shown here. The three-bar symbol illustrates equivalence. The converse and inverse of a compound proposition are also logically equivalent, meaning they have the same truth values for every possible combination, as shown in the truth table. Therefore, we can say that an implication proposition and its contrapositive are logically equivalent, and the converse and inverse of an implication proposition are also logically equivalent. Let's see another example. Here we have a compound proposition on the screen. Charlie is happy if he is healthy. Before we do it together, let me give you a moment to try constructing the converse, inverse, and contrapositive of this statement yourself. Feel free to pause the video. All right, let's do it together. Before we proceed with converting the statement, we should always make sure that the given statement is conditional, or an implication. As we stated earlier, the logical forms of the converse, inverse, and contrapositive apply only to implication propositions. Here, our statement is an implication because the two propositions, Charlie is happy and Charlie is healthy, are joined by the phrase if, which is an implication indicating phrase. In our previous video, we went through many indicative phrases to determine which logical connective they imply. To refresh your memory, you can go ahead and watch it. The link is in the description. All right, once we have confirmed that it is an implication proposition, we determine which proposition is the hypothesis and which is the conclusion. In our case, Charlie is healthy is the hypothesis, and Charlie is happy is the conclusion. Therefore, we can proceed to construct the converse, inverse, and contrapositive. As we saw earlier, for the converse, we simply swap the hypothesis and the conclusion. Hence, Charlie is healthy if he is happy, or equivalently, if Charlie is happy, then he is healthy, will be the converse of the compound proposition. The inverse is found by negating both the hypothesis and the conclusion without changing their positions. The result will be Charlie is not happy if he is not healthy, or if Charlie is not healthy, then he is not happy. The final one is the contrapositive, which is a combination of the converse and the inverse. This means we swap the hypothesis and the conclusion and then negate both of them. By doing that, we find the contrapositive to be Charlie is not healthy if he is not happy, or if Charlie is not happy, then he is not healthy. We can extract some properties from these logical forms. For instance, the contrapositive of the converse of an implication proposition is the same as the inverse of that implication. Let's prove whether this statement is true. First, we express the statement using logical notation for better clarity. Let's say the implication proposition is T implies S. Therefore, the statement becomes the contrapositive of the converse of T implies S is the same as the inverse of T implies S. First, we determine the converse of T implies S, which is S implies T, as we have seen earlier. Now that we have the converse of the implication, we find its contrapositive. That will be negation of T implies negation of S, which is exactly the inverse of T implies S. Hence, the statement, the contrapositive of the converse of an implication proposition is the inverse of that implication, is true. Now for you, prove that the statement, the contrapositive of an inverse of an implication proposition is the converse of that implication, by following the same steps we just used, and comment down below whether it actually is true or not. All right, to further reinforce your understanding, I am going to leave you with a couple of questions to practice. I have a list of implication propositions, and I want you to find their converse, inverse, and contrapositive statements. As a bonus, try to determine the truth value of each compound proposition's converse, inverse, and contrapositive statement if the original proposition has a truth value of false. And we are done. Hopefully that makes some sense and helps you navigate these different logical forms. Feel free to point out any unclear topics or other concepts you would like to be covered in the comment section below. If you find this video helpful, hit the like button and smash that subscribe button to join our community. Thanks for watching, and see you